Well, thank you for joining me on exercise 3G. I'll be looking at question 8D. It says prove the following properties of conjugate complex numbers, and we've got a Z1 over Z2, and we want the conjugate of that happens to equal the conjugate of Z1 over the conjugate of Z2. All right, so let us give the value of Z1 as A plus BI and Z2 as C plus DI, where A, B, C, D are elements of real numbers. Well, let's work on the left-hand expression, and we've got Z1 over Z2 conjugate. So substituting, we've got A plus BI over C plus DI conjugate. So that would be, let's take C plus DI and let's put the conjugate of C plus DI on the numerator and the denominator so that we can rationalize our denominator, get rid of the imaginary component. So what we have on the numerator, I'll expand that to be AC minus ADI plus BCI. And this is a minus BDI squared. The denominator is the difference of two squares. It's the conjugate. When you multiply by the conjugate, you simply get the C squared plus D squared. So it's the modulus squared. So I'll just show that this way. The modulus of C plus DI squared is if you multiply by, I'll just put it here, if you take a Z and multiply by its conjugate, you get the modulus of the original, or either of them really, and square it. So I will take that I squared here, and we know that I squared is -1. So when you've got minus BD I squared, we'll change that to minus BE times -1. So we'll change that to plus BD. So let's do that. So AC minus ADI plus BCI, we'll change that to plus BD. And on the denominator, let's just square the modulus, so it's C squared plus D squared. Let's bring the real components on the top together, AC plus BD. And let's put the I as BC minus AD. So I've taken the BC here and then minus the AD here. And this is all over, I'll put this over C squared plus D squared. I'll put this over C squared plus D squared. You know what I forgot? I've got to go back and add these. I forgot to put that conjugate on each line, like here. All right, so now we can get the conjugate would be, where there's a plus, we simply put the minus. So that would be AC plus BD over C squared plus D squared minus BC minus AD I over C squared plus D squared. Right, there is the left-hand expression. Let's do the right-hand expression. And it was the conjugate of Z1 over the conjugate of Z2. So the conjugate of A plus BI over the conjugate of C plus DI. Well, the conjugate, we simply take the plus and present a minus, so that would be a DI. Oh, so the conjugate would have a minus, and instead of C plus DI, it's C minus DI. All right, well, let's get rid of our imaginary part on the denominator by multiplying by its conjugate, and C minus, so we put a plus. That will be C plus DI, C plus DI. So let's expand this. We've got AC plus ADI minus BCI minus BDI. And underneath we've got the modulus squared, which is C squared plus D squared. Well, this was wrong here. BI times DI is BDI squared. Now I squared is -1, so we've got a minus BDI squared. That's a minus BD times -1, which becomes plus BD. So let's change that numerator. A squared plus ADI minus BCI. Change that to a plus BD. And now let's bring the real components together, which is AC plus BD. And we'll put that over C plus D squared. And the imaginary components will be plus AD minus BCI over C squared plus D squared. Now notice in our left-hand expression we've got a minus, and in the right-hand expression we've got a plus. What we could do here is if we change the order, let's leave that as AC plus BD over C squared plus D squared. If we want a minus there, we change the order here. So that would be BC minus AD. And just to get an identical expression of the left-hand expression, we have AC plus BD. The right-hand expression, we have identical expression. So you can see it's identical. Therefore, the left-hand expression equals the right-hand expression. I hope this has helped. Until next time, stay happy.